Warm greeting to all. My name is Amarnath, Assistant Professor, Department of Mechanical Engineering, Savita Engineering College. Today I am going to discuss Unit 5, a natural coordinate system in 1 dimension and 2 dimension. So previous session we discussed what is isoparametric element, what are the different elements available, and what is natural coordinate system in isoparametric element. That and all we discussed in a previous session. This class we are going to discuss natural coordinate system in 1 dimension and natural coordinate system in 2 dimension. So here we discuss natural coordinate system in 1 dimension. So we can take two noded element, and node I, node j, the length will be L. So here the local coordinate system x and the natural coordinate system epsilon. So the natural coordinate system at midpoint is 0, at node I -1, at node j epsilon equal to 1. So the relationship between the Cartesian coordinate x and the natural coordinate epsilon. So epsilon, which is equal to 2x divided by L minus 1. So if you apply a boundary condition, x equal to 0 at node I, x equal to L at node j. So if you substitute the boundary condition, x equal to 0 at node I, epsilon equal to -1, x equal to L at node j, epsilon equal to 1. So this is natural coordinate system for 1 dimensional element. So natural coordinate system in 1 dimension. So if you take 1 dimensional element with two nodes, the natural coordinates at any point is unity. You see L1 plus L2, which is equal to 1. So let us assume this as equation number 1. Any point x within the element can be expressed as a linear combination of nodal coordinates of nodes 1 and 2. So any point on the x, so we will take the equation L1 x1 plus L2 x2, which is equal to x. This is assumed as equation 2. So these two equations we have arranged in form of matrix. So 1 x1, 1 x2, L1 L2, which is equal to 1x. The next we can find the value of L1 L2. So L1 L2, they bring the 1 x1 1 x2 from left hand side to right hand side. So it will get an inverse value. So this inverse we can find out using this formula, A inverse, which is equal to 1 by determinant A adjoint A. So with the help of this formula we can find the inverse value and we will get the solution of L1 and L2. So L1, which is equal to x2 minus x divided by L, L2, which is equal to x minus x1 divided by L. So this is for 1 dimensional element L1, L2. And natural coordinate system in 2 dimensional element. So here we consider three noded element A, B, C. So consider three triangular element having 3 nodes, L1 plus L2 plus L3, which is equal to 1. So that is natural coordinate system, any point is unity. Then similarly same as 1 dimensional element, here L1 x1 plus L2 x2 plus L3 x3, which is equal to x. Addition to this, we will have a y-axis, L1 y1 plus L2 y2 plus L3 y3, which is equal to y. So we will get 3 equations. So we have to assemble the above equation 1, 2 and 3 in matrix form. So if you arrange this in matrix form, we will get the solution 1 x1 y1, 1 x2 y2, 1 x3 y3, L1 L2 L3 which is equal to 1 xy. So this from this we can calculate L1 L2 L3. This we have to take in the right hand side, we will get the inverse value. Again the same formula, the inverse value using this formula A inverse which is equal to 1 by determinant A adjoint A. So you have to find out the inverse value with this formula, and we can find the value of L1 L2 L3. so this we can calculate L1 L2 L3 which is equal to 1 by 2A x2 y2 minus x3 y3, y2 y3, x3 minus x2, x3 y1 minus x1 y3, y3 minus xy1, x1 minus x3, x1 y1 minus x2 y2, y1 minus y2, x2 minus x1, 1 xy. So this 1 by 2A. So we have to calculate the area and we have to multiply with this. So this value and this value is similar. So you have to cross multiply. We will substitute as a 2A. So this is for two-dimensional element. Up to this we discussed a natural coordinate system for one dimension and two dimension. The next session we will discuss the shape function for the one dimension and two dimension. Thank you.